Thank you. Welcome to this session. I'm very excited to be here at the conference, and I'm very excited to stand here in front of you to talk about the subject that I'm very passionate about. My name is Per, and I build software for business and for pleasure. How many of you build software for a living? Great. And for fun? Great. So someone little, maybe not? No? Great. So we have that in common. Now, when I build software, I like to be in control. I'm not saying I'm a control freak. Other people say that. But I like to be in control of how the software behaves in the hands of the users. And I like to be in control over how we develop the software. And I think that test-driven development is one of the most important tools that we as software developers can use to be in control. And I used to think that test-driven development is a personal tool, something like typing on a keyboard, right? And I would do it to become a better developer, to write better code. And I could accept that other people weren't doing it, because it takes some time to be fluent, and maybe they haven't seen the light yet. But I've changed my mind. Now I think of test-driven development as surgical staff washing their hands before an operation. So surgical staff will wash their hands to get rid of bacteria, to decrease or remove the risk of infection. What happens if only one or two on the staff does that, and the other, they just get in there with their dirty hands? Then the effect of, reducing the risk or removing the risk for infection goes away. And it's the same way with test-driven development. Unless we all do it, the effects we gain from it won't be there. So, does the T in TDD stand for team? Let's find out. But before we talk about test-driven development, let's talk about something else. In your average development project, something increases over time. Something in the beginning of the project is very small, and over time it builds up and becomes very large. What is it? Complexity. Something else?
Code.
Sorry?
Code.
Code, yes. Also, no. Sorry? Time spent to fix bugs. Also, okay, knowledge. So in the beginning of a project, we know very little. And as the project goes by, as time goes by, we will learn things. We will learn things as we develop the software, as we communicate with people, and as we fix bugs and watch requirements change and so on. We learn more. And this has a profound effect on how we build the software. Because in the beginning of the project, with very little knowledge, what can we do? This is real life. This is our domain. Our domain is what we build the software to operate in. And this picture is, I like it very much because there are so many things in it, so many details. We have the trunk and branches, and we have the foliage leaning, and we have the grass, and we have the stone and the shadow, and the grass is green, and the grass is brown, and there's a bench, and there's ocean, and there are mountains. There are a lot of details. But in the beginning of our project, we don't have full knowledge of this domain, so we can't really build our software to be this. And we never can. We will never be able to build software that exactly mimics the domain, and neither should we. We should always simplify. So in the beginning, we will create a model of our software, and the model will look like this. Do you recognize it as a tree? Good. So my drawing skills are not that bad. I have the trunk and I have the foliage, but you can't see individual leaves. I have the grass in the ground, but there are a lot of details here that I have left out. But this is probably sufficient in the beginning of the project to, model what we need. But as time goes by, we learn more and more. We get new requirements, and we realize that this simple model isn't enough to represent our domain and to meet our requirements. So what do we have to do? We have to change it. We have to do something with the model to enrich it, to incorporate new details from the domain into the model. We need to change. In this case, I added some colors. But I still haven't taken in all the details. There are many details left that we can take in later. So, change. And almost 40 years ago, Barry Beam talked about the exponential cost of change. That early on, it's cheap to change software. Later on, it's expensive to change software, especially after you have released it. It's extremely expensive. So this was like the model for cost of change of software. And then 20 years later, almost 20 years ago, in 2001, almost 20 years ago, Kent Beck came along and said that, what if the cost of change can be like this? That over time, we don't get the exponential increase. Instead, we get the curve that, from your perspective, flattens out like this. And how can we do that? Well, this was the extreme programming book, right? And the central thing there is embrace change. Things will change, requirements will change, your knowledge will change, your models need to change, and adapt the methodologies and everything you do to the fact that things change. And to be able to do that, we need tools. Test-driven development is one of those tools that allow us to embrace change. Now, I have a dream situation. In every project that I'm in, I want to be able to say this. If I, with good intentions, change some code, and then I run the tests, and all of the tests on existing functionality are green, then I didn't break anything. Can you say this on your project? Raise of hands. Anyone? Oh man, no one? I can do it. This is what I strive for. This is what I want. And we can put this a bit differently. Do you have new people coming onto your teams? So a new developer comes in and is assigned a task and says, I don't want to touch that code. I'm afraid of breaking it. Can that happen? Yeah? Yeah. Now the old developers, and I don't mean old, I mean like the young and fresh existing developers, they say, don't worry. If you break it and no tests fail, it's our fault. Because then we haven't created the test suites necessary to catch failures, to catch mistakes. I want to be in this situation. Do you want to be in this situation? Does it sound okay? Oh, okay, some of you. Very nice. So the question is, how do we get there? How do we get from where we are now to be in this situation? And the answer is, of course, test-driven development. But to be a bit more nuanced, I have 4 things I want to talk about. And I realize that's a problem, because you're supposed to have 3 or 5, right? So we'll see how this goes. The first thing I want to talk about is to have bug-free and comprehensible tests. And I realize that you think, do we really need to talk about bug-free? Isn't that obvious that we need to have bug-free tests? Or comprehensibility, isn't that really obvious? And I suppose it is, but I review a lot of code. I read a lot of code. I spend a lot of time looking at code, and tests in particular, before I go to bed. And I have seen many tests that are buggy and hard to understand. And it just surprises me every time that this is an issue. But it is. So let's talk about that a little bit. I want to have intention revealing tests. Tests that, when we look at them, tell us what they are and why they are, that we can understand them. I want to have tests that support refactoring. So, in this situation I painted, I said that, implicitly, that I want to have a test suite that is comprehensive and that can catch mistakes easily, so that I can have freedom to change. But when I do that change, I also want the tests to, allow that change, so that the tests survive and can still be used after the change. And finally, I want to have discipline and no cheating on the team. And I realized that no one in this room would ever cheat or lack in discipline, but perhaps someone else on your team could do that. So let's talk about that a little. So what happens when we have this? Well, we on the team can boost each other's productivity by using test-driven development and by thinking about these 4 things. We can help each other be productive, which I think is a good thing. And we can reduce the risk of making mistakes. Actually, we can't reduce the risk of making mistakes because we're human beings. I think most of you are, at least. But we can reduce the risk of those mistakes getting unnoticed into production. That's the risk we can reduce. We can enable safe refactorings. Anyone can change some code, refactor some code to be better, and that's okay, and things will still work. And we can remove drama. We can deploy on a Friday afternoon to production, and then go home and enjoy the weekend. Who here likes to get a support call on the weekend? No more, right? We don't want these nasty surprises. We want to be relaxed and safe and calm. I sense an objection. I think somewhere in the audience there is a person thinking, well, hold on, isn't it the automated tests that is important here, rather than test-driven development, rather than how the tests were written? And sure, it's true in some way. However, I think that when we use test-driven development, we get a test suite, a suite of automated tests that are good and that can help us very much, and actually can allow us to be in the situation I painted before. If we, on the other hand, use test after, has anyone used test after? Written test? Oh, okay. Tests written in that fashion tend to be buggy, hard to comprehend, and not so good. I think actually that writing tests after is one of the hardest things we can do. Right? Naming, caching, validation, writing tests after. So, you know, if you compare things, test-driven development is actually simpler. I'm not saying it's simple, I'm saying it's simpler than doing test after, in my opinion. We don't even need to talk about no tests at all, because that is really hard. So, I suppose you're familiar with TDD, but let's just go through it anyway, just shortly, because it's really simple to explain the core of it. So, you start with a red test, and this is the most important part. The test must be red. If the test is green, then something is wrong. Either the code that you were about to write already exists, or the test is buggy. The test doesn't really, you know, test what you intended it to test. So it must be red, and then you write some code, so the test goes green, and then you look at that code and you improve it so that it becomes nice and clean. And then you go on to the next red test, and green, and you refactor, and so on, until you're done. It looks really simple, right? There are a lot of other things to think about. We need to start with a base case. We need to start somewhere with the test so that the code we write is like as simple as possible, the starting point. And we need to take small steps to have a quick feedback loop, so that as soon as something starts to go red, we know why, because it's because of what we just did. So not write one test, implement the entire system, and then why does the test go red? We create the simplest possible solution. And actually the simplest possible solution might be a bit hackish. It might not be very nice. Its only job is to make the test green. And then we continuously improve the code through the refactoring step. So in the end we will have nice clean code, and we will have a suite of tests that are with bug-free tests. So let's go on. And I want to say that test-driven development is crucial for long-term productivity in any well-functioning team. And I say long-term because in the short term we can always hack. You know, we can always write some sort of workaround or hack that and get that out of the door and make the code work today. But if we want to have a sustainable long-term productivity, we need to be methodological and to use test-driven development. And I write well-functioning team because in a team there may be lots of problems. And in the environment that the team operates in, there may be lots of problems. And of course, some of those problems are so big that not even test-driven development can fix them. Do I mean any team? Yes. Small team or big team. In a big team, there will be more communication, of course, so perhaps even more important there. But as soon as you are 2 people or more, I think this is very valuable. In a co-located team where you can communicate freely is important. In a distributed team all over the world in different time zones, it becomes even more important. It can even be just one person. You, and in 6 months, the future you. Have you ever looked at code and thought, this is crap, who wrote this? And you do git blame and it says, you wrote it. You forget, you learn more, and you look at your old code in a new light. And then the tests are there to help you. Okay, bug-free and easily comprehensible tests. What does bug-free mean in this context? Well, the point is that only bug-free tests can be relied on. If I want to be in a situation where I can change code, run the tests, and say, they are green, so I haven't broken anything. If I want to be in that situation, I need the tests to be bug-free. Because if they're not, why are they there? If they aren't bug-free, if there are bugs in the tests, then they're pointless. But it gets even worse, because if the tests are buggy, then I get a false sense of security. Then I will stand and say, I can change anything, and the test suite will catch my mistakes, but actually it won't, because the tests are buggy. So the test suite will be green, and I will have made some mistakes. So we need to write tests that don't have bugs. And my favorite example of a buggy test is this. We have a user database. The user database isn't my favorite thing. It's the structure of the test that is so good. SUT here stands for subject under test. So we create a user database and we register a user. And the point of the test is, as the name suggests, to ensure that the user database rejects duplicate, that the user registers twice. So we register a user, and then we register the same user again, and we verify that the exception we get is a duplicate email exception. Where's the bug? Sorry? Exactly. So this test works as long as an exception is thrown, because then it verifies that the exception is duplicate email exception. If some other exception is thrown, then the test goes red. So it seems nice, right? But if no exception is thrown, then execution will just fall off the edge towards the end, and the test runner will think that everything is fine. And of course you wouldn't write a test this way, because there are assertion, you write like assert.catch or something, and the assertion framework would actually take care of checking that an exception happens. But I've seen tests like this. Have you? Have you written a test like this? Yeah? So if we have a test like this, then we have a problem, because now we cannot rely on our test suite anymore. What about easily comprehensible? We want that, right? In our code and in our tests. So suppose you get a notification that a build has failed on the build server, or before that you run the test on your machine and you have a red test. And you look at the test that has failed, and you have no clue what it does. You don't understand why it fails. You don't see the connection between what you just did and what the test does. Is that a good test? Is that something we can use? Tests that we cannot understand are friction. Normally, because tests are code, and code has a cost, right? But normally, tests bring a lot of value, and the value offsets the cost, so in the end, we have more value than cost, and that's good. But if we have tests that we can't understand, tests which are friction, then the cost is higher than the benefit of the value. And then we have a problem, because now we have something that each time we're there to look at, we need to spend a lot of time on. I thought, what should I give as example of a hard to understand test? It's probably hard to give an example that is completely impossible to understand, because then I won't be able to explain it myself even. So I thought about something simpler. We create a haystack, test. So the haystack is the subject under test. And we add some items to it, including hay. And then we have something in the middle where we take out the items, we select the value, and then we have a filter to find the needle, and then we use first or default, which takes the first needle or null, right? Which works because strings can be null. If we have structs, then it would be a lot worse. And then we verify that we get not null. Do you think this is easy to just, at a quick glance, understand? I mean, I suppose some of you are more fluent with LINQ than others. So some might just look at this, like, matrix scrolling down and see all the patterns. But I think there's a lot of noise in here. And the noise makes it a bit hard to understand, to quickly see what's going on. And you can imagine that it can be much worse. Have you ever been in a situation where ReSharper says to you, oh, I can convert this into LINQ? And you click the button, and all of a sudden you have this LINQ expression, which is completely, okay, I have some of you, yeah. And if you leave it, then you might end up with hard to read tests. So I would argue that if we have something like this, then it's much easier to see what's going on. We create a haystack still. We have a helper for it, which means that we can avoid the new and the braces and the whatnot, all the noise. And then we have another helper that says, give us all the values from the items from the subject under test. And then we use a proper assertion to say asserted values does contain needle. And I think this is much, much clearer. And if we look at the test that looks like this, I think we can quicker understand what's going on. And if this fails, we can quicker understand why it fails. Do you agree? Do you write tests in this way? Some of you? Yeah, good, excellent.
Well,
oh, you have a question?
No.
No, okay. Oh, okay. Cool. So what's the solution? When we have the red test, which is the first step of test-driven development. So, I mean, it's there when we do test-driven development. We don't have to go through extra steps to make the test red. It's red from the beginning. We observe the failure. We make sure that the test is red, and we observe the failure. We make sure that the test fails for the correct reason. And if it does that, then we can say that it's bug-free. And why do I do air quotes? Well, because we can never guarantee the absence of bugs. And I mean, if our understanding of the requirements is wrong, then of course the test will be buggy by some definition. But it can be as bug-free as we can make it. And after you have written the test, read it. Does it make sense? It's easy to write code, to just churn out code. But if you take a step back and read it, does it make sense? Or ask a colleague to read it. Make use of well-named test helpers. Extract the noise from the tests to readable test helpers that allow you to focus on what the test really does. It can help a lot to make tests comprehensible. So the next success factor was intention revealing tests. Okay, what does that mean? Suppose that we have tests that are bug-free and easily comprehensible. Okay. In this case, we can look at the test and we can probably easily understand what it does. But can we understand why it does it? Is it obvious if we look at the test why it asserts in a certain way? I mean, at some point, someone said you shouldn't write test that x does y. You should write it should do y. And if I see a test that says something should do, I immediately think, should it? Is that correct? If I can't see why a test does what it does, I think it's arbitrary. And arbitrary tests are also very dangerous. Because if an arbitrary test fails, does it mean that I made a mistake? Or does it mean that I have changed like the prerequisites for the test? For example, we had a new requirement, we needed to make a change to accommodate the new requirement, and an old test failed. Was it because the old requirement and the new requirements are incompatible? Or did I break something for real? I don't know. And if I don't know, how am I supposed to fix it? What am I supposed to do? So if you compare just two test names, and you can tell me what you think. So we have one test that says that some piece of code should draw an icon at 9292. If you would see that fail, what would you think? Why do we need an icon at 9292? I have no idea. Perhaps we can look at the code or the test and see, okay, there's a canvas, it's 200 by 200, and the icon is 16 by 16, so yeah, it probably has something to do with centering. But if the test instead said we should center the icon vertically and horizontally, then it's much clearer to understand what the test is about. The intention of the test is much clearer, just by changing the name a little bit. We can also look at how a test fails. Was any of you at last year, Swetug? I talked about test failures. If we have a test and we verify that something produces colors, and we say that assert true colors contains blue, how does this fail?
It's false.
Yes, it says expected true but was false. And if we have this failure on our build server, what do we know? We have no idea. We just see we have something should provide colors, expected true but was false. We don't know what the intention of that test was or why it fails. We have no idea. If we instead write the test using a proper assertion, assert that colors does contain blue, then the failure looks quite different. Now the failure is expected some item equal to blue, but was red and green. And now we can look at the test on the failure and see what the test was about. Aha, it was about looking in a list of colors and seeing if some color was there and it wasn't. And we see why, because it's missing. I mean, in the previous test, one reason for not finding blue with a capital B could be that it was misspelled with a lowercase b, or spelled in a different way. Blue with many U's, something like that. So it's much clearer. The intent of the test is much clearer, I think. So some ways of showing intent. What we saw as an example, name the test appropriately. Make sure that the name of the test communicates what the test is about. I suppose that you're familiar with given when then, or arrange, act, assert, basically the same thing, a way of structuring your tests. If we make that very clear, then someone can look at the test, at the context, at the given, what happens, and the assertion, and probably follow what's going on. But if you muddle these up, and if they're not clear, then it will become much harder to know why a test is there. Sometimes I like to include a because in the test name. I write a test, I name it, and after having given it a name, even if I strive to have a clear name, I think, as I thought before, why should it? I've just written it should do X, and I think, why? If someone looks at this test a month from now, they will wonder, why should it do X? So I add a because. Because of backwards compatibility, or because something else. And of course, as you can imagine, we can't write a full story in the test name, but sometimes I think we can add small clues. in the test name to help a future test reader understand it better. Right. And when the test is read, that is, in the first step of the test-driven development cycle, ensure that the failure output is clear, so that someone that looks at the failing test can easily understand what's going on. And you have that opportunity as soon as you start doing test-driven development. Another thing I think is very helpful is if we assert behavior, that we assert the solution to a problem. So when you start writing a test, there is a problem. There's something that the code doesn't solve yet, right? So the test will like set up the conditions, execute the code which doesn't do what it should, and then verify that the result is something. You assert the behavior that you want. But should you write a test after, the risk is that you actually assert just the implementation. And then the test becomes locked to the implementation. It's hard to understand why the test exists, because all it does is like parrot the implementation. And now you have a hard time changing the implementation to something better because the test is very tightly connected to the implementation. So try to assert the expected intended behavior and not care so much about the implementation. All right. The next part, tests that support refactoring. We have multiple levels of test, and I won't go into a discussion of all possible levels and what they are named, but let's just talk about two levels. So we have unit tests that verify individual pieces of logic. They're often quite detailed. And then we have functional tests, and the functional tests verify that the units actually fit together, that when you put them together, they do something as a whole. I also think of these as flow tests, because they typically test the flow through your application. And as you can imagine, both tests on both levels are important. We need unit tests and we need functional tests, because on a functional test level, we test pretty high-level stuff. But on a unit test level, we can test very detailed stuff, and we can test with big variation. So they complement each other. And I think test-driven development can be used on both levels. I suppose some people will say that when you do TDD, you do it on a unit level, but I think I can write a test on a functional level and then use that test to drive my implementation. Sure, the steps will be a bit bigger, but I can still use the same process. Now they differ in implementation dependence and they differ in brittleness. What do I mean by that? Well, if you refactor something, if you change code, chances are that the unit tests will not apply anymore, because perhaps you changed the units. You no longer have the same units, you have new units, and some old units are gone. So the unit tests are no longer applicable, but the functional tests, on the other hand, can still be there, because they tested the flow. So unit tests are more likely to fail than functional tests, probably. On the other hand, if a functional test fails, it can be hard to know exactly where something went wrong. If a unit test fails, it's often easy to pinpoint exactly what went wrong. So again, they complement each other. As an example, let's say that we have this. How many of you write compilers? One? Only one? You should write more compilers. It's really fun. So typically when you write a compiler, you have a number of phases. And there can be more phases. It just fit 4 in here. So we have the lexing, where you just take the stream of characters and you create tokens. You recognize identifiers and keywords and stuff like that, strings and numbers. And then you parse that stream of tokens into something like an abstract syntax tree. And then you do some sort of semantic analysis on that AST, and then you generate code in the end. And also typically there is some sort of optimization going on. Because the compiler is often smart enough to know that if you have written some code, it can do it a lot faster than how you wrote it. But for some reason, the person who wrote this compiler actually just put optimization in all steps. A little bit of optimization during indexing, whatever that would be, and in parsing and so on. And then someone comes along and say that this is difficult because the optimization is like highly coupled to the other steps, and we have a hard time adding new optimizations and something like that. And they look at the tests, and the tests are like unit tests. So we have tests that test lexing, parsing, semantic analysis, code generation. Those are the tests we have. But it should be okay, right? Because we have good coverage. And what the person wants is for that picture above to become the picture down here. So they want the optimization to be a separate step right before code generation. Do the tests help us do this? What do you think? No, they don't. Because we have tests on each individual step, but we don't have tests on the flow. So now when we pull out the optimization parts into their own phase, the tests may not apply anymore in the place where they were written. Maybe we can reuse the test. Maybe with hard labor, we can take the tests and tweak them a bit so that they apply to the optimization phase instead, provided that they weren't written like so they tested lexing and optimization like this, because then it's hard to pull them together. So this is something we need to think about when we write tests. If we do big refactorings, structural refactorings, will the tests help us? Another example, which apply on the functional test level, functional tests, being on a high level, often use complex data. So for example, imagine that you have code that reads an Excel file. And you have a test that says, assert that items from Excel file has count equal to 5. Is that a good test? Is that a test that is robust? Anyone?
It very much depends on the Excel file. If it is an Excel file used just for this single test, then it's robust, yes. But if you go the way that you have the one Excel file that you use for every single test, then you add a line somewhere else.
Yes, exactly. So you have that single Excel file used for all tests, and you get a new requirement, and you add a new row to test some aspect, and all of a sudden this fails. It says expected 5, but was 6, because you have a new row. But so wouldn't it be much better to test, like, take the names of the items from the Excel file and verify that all the names is a superset of some of the expected names? Or possibly say that it should have at least 5 items? When we write the test, we can think, will this fail if someone takes our test data and uses it for another test? How can I write the test in a way that someone else on my team is free to change the test data and my test will still go green? So we can work with assertions to do this. So we plan for refactoring. We write unit tests, of course, because they fill a purpose, but we realize that they may need to be sacrificed. If we do structural refactoring, we might need to throw away the unit tests. That's fine. But since we know that, we can plan for how that will happen. The functional tests are more stable over time, of course. Maybe we can reuse the unit tests, given that they are bug-free and easy comprehensible and intention revealing. We can probably take them and move them to other places, at least some of them, which is a good thing. But if we don't understand what they do, then just throw them away. And then the risk is that we miss something, of course. We want at all times to make it possible to improve implementation details, because as I said in the beginning, things will change. And I think that anyone on the team should be able to do any improvements that is necessary. And we need the test to support that. don't test private parts. I hope you don't do that. Do you test private parts? Do you use reflection to test?
Done that, yes.
Yeah, yeah. Been there, done that.
Yeah.
Yeah.
And not a good idea, but sometimes hard to avoid.
Maybe. I think there are techniques you can use. But sure, in a legacy code base, where you need to test something which is hard to reach through the public API, perhaps because the public API throws up some UI dialogue or something strange, you use reflection and you test private code. And when you do that, all of a sudden you have a test suite that is extremely tightly coupled to the implementation. And it becomes very hard to do refactorings. It becomes very hard to embrace change. And finally, discipline and no cheating. Again, not an issue here, right? Oh, good. So let's just pretend that we have a system without automated tests, or that we have a system with just a few automated tests. Does anyone work with a system like this? A few? Yeah, yeah, it happens. Especially perhaps old systems that have grown a lot over time. Now the consequences are that doing a refactoring ranges from hard to impossible. Big refactorings can be hopeless because there's so much uncertainty. We don't know really what will happen if we do big changes. And the result is, of course, that we won't do the changes. We'll just add some code somewhere else and, create a bigger mess. Improving performance is very risky because improving performance often means, refactoring. And refactorings are hard. If you do a refactoring anyway, you can count on just a fresh set of bug reports coming in from the user because you will break things. Not a good place to be. I imagine code in a big legacy system to be something like this. It's a maze. And to get from one point to another, it's not a straight path. It's quite complex. And how do you write a test for this? It's very hard. There are a lot of bends and places where you can go left and right, and if you go wrong, you will just be lost forever. So how do you write a test for this? And the answer is that it takes time. It's hard. Writing the first test in a code base where you don't have tests is really, really, really hard. Had we used test-driven development, this wouldn't be a problem, of course. But this is very hard. So what happens then? What happens is that someone needs to take the bull by the horns and write the first test. Someone needs to invest the time, because once that first test has been written, the rest are much easier, at least for that particular area of the maze. Who will take the bull by the horns? Well, no one, because we have time pressure, we have a delivery, and we need to get things done. So we will not do that right now. We will wait until some later point to do that. And then we have a vicious circle, because the next time someone sees that code, I need to do it, but not now. And I will add some more code here, and someone sees that code, I need to write a test, and that won't happen, and so on. It can look like this. We have a number of, well, the contrast is a bit bad. Those are supposed to be a gray background. So we have a number of issues here, and there are bugs, and we have features going on, and somewhere in the bottom there's this, we need to write tests. And in reality, this with the Jira and the backlog would be like 200, 300, 400 items, and that would be in the bottom. Have you had a task like this? Yeah. So it won't happen. Who will prioritize that, right? No. If I encounter untested code, my productivity drops drastically. So, and that can be for one of two reasons. Either it can be because there's a bull and the bull has horns, and I'm the person who wants to grab those horns. So I will now, write test. Or because I don't write test and now I'm in a minefield and I need to step very carefully to be able to navigate through that. And remember, we're supposed to boost each other's productivity. We're supposed to help each other be productive. And if I encounter untested code, someone has not helped me be productive. So, write that first test. Pave the way. Allow your colleagues to be productive and change things. And write more tests. Even the first small test, provided that it's bug-free, comprehensible, and so on, has value. And one big value is that if we write that test, then the code that it tests will sort of have increased testability. And if we have testable code, then we can have higher test focus and write more tests. And then we have a good circle going on, something that increases our test focus. So, in summary, the 4 things: bug-free, easily comprehensible tests, intention-revealing tests. We want to have tests that support refactoring, and we want to have discipline and no cheating. And if we have this, then my point is that we're writing tests for the team, so that everyone in the team can refactor, do changes, and say that if I change something and all the tests are green, then I didn't break anything. We maximize the team productivity. Okay, good. Where do you go from here? Go home. Well, not now. After the conference. Review your test suite. Is it team friendly? Does it fulfill these criteria? Can you say that these are good tests? They will help everyone in my team to be productive. Do you have low test coverage? Prioritize that task down in the Jira. Write tests. And give as much attention to your tests as you give to your production code. Thank you for listening. We might have time for some question, perhaps. Anyone?
So what is the ideal code coverage?
The ideal code coverage is a non-question if you use test-driven development, because then by definition your code coverage is as good as it can get. Because there will always be code that is hard to test, like exception handlers for weird network I/O conditions, something like that. So I believe that the ideal code coverage is such that I can go anywhere in the code and feel safe about doing changes. So without giving a number, that is what I think. Okay. Anyone else? If you ask me, then yes, but there are of course exceptions to every rule. So if you're writing like some sort of test data provider or test runner for your own tests, then maybe you don't have tests on the test runner. I mean, most of the time, yes, all code should be tested, and then there are exceptions. But I think the starting point should be yes. Okay, anything else? Okay, again, thank you, and I wish you a pleasant day.
Thank you.